All right, we're going to look at 8.4. And 8.4 is looking at variation models. So when we look at these, we're essentially saying or describing the relationship between our variables, and that's what variation is. We're not going to focus as much on direct variation. We're going to look at joint and inverse variation, and then we're going to identify some equations, but that's not as important. We're going to go to some examples of joint variation and inverse variation, and I'll show you how to set those up and solve those. So they're not too bad once you understand how they work. And then once you understand how they work, there's kind of a cheat code we can go ahead and set up to use them. So let's look at just our basic formulas for this. So for joint variation, that is if y varies jointly as x and z, essentially we're saying y is equal to k times x times z. And k is just a constant. So k is like 2, 3, 4, 5, whatever. K is just some number here that is a constant no matter what we're plugging in for y, x, and z. So that's what joint variation looks like. We're just essentially saying y is equal to k times x times z. When we look at inverse variation, that is if we say y is inversely proportional to x, we're saying y is equal to k, which is a constant, over x. So that's just saying the relationship between y and x is that y is inversely proportional to x. So y is equal to some number, some constant k over x. And then back to joint variation. If y is just jointly proportional to x and z, that's just saying that y is equal to some number k, some constant k times x times z. So if we want to look at identifying some equations where we see this, it's not too hard. Like I said, we're not going to worry too much about direct variation. We're going to look at joint and inverse variation for this section. So if we go to number 2, we're essentially just looking for the same setup as y equals. If we're looking for inverse, we're looking for y equals k over x or some number over x. And if we're looking for joint variation, we're looking for y is equal to some number times x times z. So when we go to number 2, we've got y is equal to 24 over x. So we would say that this is a joint variation and our k is just equal to 24. So these aren't too hard. I don't think I'm going to put any of these on the homework, but I'm just going to show you some examples of them anyway. They're not too hard to identify, though. Actually, I may make you do some of these. Never mind. Scratch that. You will do some of this. But it's not too complicated. You're really just looking for the joint variation setup or the inverse variation setup. So if we go to number 3, you'll see we've got y is equal to 5xz. Anytime you see x and z, that's probably an indicator, or anytime you see two variables here multiplied, that's probably an indicator that it's joint, which I just did this one wrong. This would not be joint. This would be inverse. I don't know what I was thinking. So this one would be inverse variation because we've got y is equal to 24 over x, and k is just 24 there. So then when we go to number 3, anytime you see x and z or two variables, like I said, it's probably going to be joint. So this is a joint variation problem, and k is equal to 5. So our constant here is just this 5. And then we can even go to a more complex problem like on number 5. The only thing that you've got to do on number 5 is just set this up to y equals. That way we can figure out if this is joint variation or inverse. So we would have to divide by x on both sides, and we would get y is equal to 36 over x. And now you can see that's an inverse variation problem. So we would say inverse and k equals 36. And then let's see, the last one we'll look at is number 6. So number 6, like I said, we need this to be y equals, because if you go back to our original general formulas for this, or general equations for this, both joint and inverse are set up y equals. So if you have anything that's not y equals, you're going to have to make sure you set it up y equals. So if we look at number 6, we would need to get rid of this 4 over 3, and you could just divide by the reciprocal or multiply by the reciprocal. So we would multiply each side by 3 over 4. So we would get y is equal to 3 over 4 xz, and that is going to be joint variation. So let's see, we would have joint, and k would be equal to 3 over 4. So that's just identifying our variation depending on when we just have a general setup. So on your homework, you'll have to do some of this, but I tried to make them pretty straightforward for you. They're not going to be too hard. So let's look at actual joint variation and inverse variation examples. So to understand these, we're going to look at the problem first, and then get into some of the calculations, because I'm going to show you kind of a shortcut that you can use for these. But I want you to understand why we're using that shortcut. So when we look at joint variation, number 12, it says, if y varies jointly with x and z, and y is equal to 48, x is equal to 8, and z is equal to 15, we need to figure out what y would be equal to when x was equal to 14 and z is equal to 20. So here's what we essentially got to figure out here. We've got to figure out our constant k, and if we can figure out that constant k, or this is the long way of doing it, if we can figure out that constant k for joint variation, we can just plug in all of our numbers and we can figure out what this is equal to. But I'm going to show you a shortcut, because what you're essentially doing here is you're essentially saying, if we go to our general formula, we've got y is equal to kxz. So if we need to find k, we can actually set both of these up equal to both of these equations. We can set two equations up equal to k, and we can set them equal to each other. So if we want to figure out what k is equal to here, we would just divide by xz, which this is just kind of for your information. But make sure you just understand this. So when we set up whatever k is equal to for inverse, we'll have k is equal to y over xz. So here's what we can do with that y over xz. If y is equal to, or if k is equal to y over xz for when we have this first set of variables, then that would mean 48 would be y, x would be 8, and z would be 15. So that's what that would look like if we just set up this proportion here, this fraction here. Y over xz for the first set of variables you're given. All I did was plug in 48 for y, x for 8, or 8 for x, and then 15 for z. But what we can do, since we know that k is equal to y over xz, we can set this equal to the second set that we're given, and we'll actually figure out what our problem is, because we're essentially saying if k is equal to y over xz, then we can set up that same fraction for y, for our second set of y, x, and z, and we can make a proportion out of it, and then we'll figure out what y would have to be in this proportion. So if we want to set up another equation, and this is just something you'll have to remember for joint variation, this is kind of a cheat code. Whenever you see joint variation problems like this, the way that you solve it is to set up a proportion. And y is on top, x and z are multiplied on the bottom. And then what you'll do with the second fraction or second proportion is y on the top, which we don't know what y is, that's what we're looking for, and then x and z on the bottom multiplied. So this is your cheat code. If we wanted to do this the long way, we would figure out what k is from the first problem, and then just substitute k back into our joint variation problem. So you could do this two ways, but it just makes life a lot easier on you to go ahead and set up this proportion. And the way that we know to set up this proportion, like I said, is that if k is equal to y over xz, then that's going to be one of our proportions here. We can set up the same proportion and just set it equal to each other, and then we'll be good to go, because all we've got to solve for is this left out variable that we've got, which is y. So if we want to solve this, this is just a proportion problem. We've got a single fraction on each side, so we can cross multiply and solve. So when we cross multiply, we'll end up with 48 times 14 times 20. And actually, let me do this. They didn't give us a lot of room here. All right. So we'll have 48 times 14 times 20 equal to 8 times 15 times y. So 8 times 15 times y. So now all we've got to do is multiply here and then solve for y. So if we multiply, we will be left with, we'll be left with 13. 48 times 14 times 20. Let me just make sure. 48 times 14 times 20 is going to be 13,440 equal to 8 times 15 y, so that would be 120y. And then all we've got to do here is divide by 120 to solve for y. So we'll end up with y is equal to 13,440 divided by 120, and that's going to be 112. So y is equal to 112, and essentially all we did there was take what we know about our general joint variation equation, and we set that equal to our constant. And once we set that equal to our constant, now we know that we can set up a proportion with y over xz, and we're just essentially saying y over xz is equal to y over xz. And the only thing we didn't know that wasn't given to us in the problem was this y here. So that's what we found. So now we know that this y is equal to 112. So our answer here is 112. So on joint variation problems, your cheat code for this is that you're just going to set up a proportion for these, and it can be with any variables. So if we look at 13, we've got if p varies jointly as q and the cube of r. The only thing that changes here is now we've got p equal to k times q times r to the third, because it just adds that we had this cube of r. That's the only thing here that's really any different, which let me look at the homework to see if there's any problems like this. I can't remember if there are. Yeah, which we'll probably work those possibly in class. But that's the only thing that changes there. Everything else is the same. So if we wanted to make this our proportion would just be p over qr to the third. So we would just set up two proportions with p over qr to the third and set those equal to each other, and then we'd be good to go, which will probably work an example like that, or I may work this example in class for you. But joint variation, just remember that you're going to set up a proportion for those, and the setup is going to be y over xz, or you may have to set it up like on 13 with p, q, and r, but pretty much is pretty simple. Whichever one they give you first, that's the one you're going to use and set everything else equal to it. So let's move to inverse variation. So inverse variation is very similar, except now we're going to use our general form or general equation to set up another type of equation for us to solve these. So if we look at inverse variation, we have y is equal to k over x. So if we want to know what k is equal to, all we've got to do here is multiply both sides by x. So we'll end up with xy is equal to k. So that's what we're going to use to try to set up a proportion or an equation to solve for either x or y. So if we look at 15, it says y is inversely proportional to x and y is equal to 7.5, x is equal to 8. Figure out what x is when y is equal to 5. So what we're going to do here is essentially set up this equation twice. We're going to say xy is equal to xy, and then whatever's left out, which in this case is x, we can just solve for that because we're given x and y and the other y. So now let's set that up. So if we set up x times y from our first variables given, we'll have 8 times 7.5 equal to x is what we're looking for, and then y on our second set of variables is just 5. So we're actually going to have 5x here. So in inverse variation, you set up a multiplication where x times y is equal to x times y. So on joint variation, we had y over xz. For inverse, your cheat code is just xy equal to xy, or just x times y. That's all you've got to really remember. Or it may be given to you in a different set of variables, but it still doesn't matter. You're essentially multiplying here with inverse, and you're dividing here or setting up a proportion with joint. So if we want to solve for this, all we've got to do is multiply 8 times 7.5, which that would be 60, equal to 5x. Then we would divide by 5, and 60 divided by 5 is going to give us 12. Yeah, so x is equal to 12. So essentially, we just figured out what this x was here. And the reason that we can do that is because we just solved for k, which I'm not making you do that. I'm just kind of giving you the cheat code to remember because it'll make life easier on you down the road. You just got to remember that when we're looking at joint variation examples, we can set up a proportion to figure out the variable that we have left out. And we set that up by using the first variable we're given, which is probably going to either be y or maybe in our 13 it's p. We're going to set that first variable as our numerator, and then all of our other two variables are going to be the denominator. And we just set up that proportion twice equal to each other, just like we did here in 12. And then on inverse variation, it's a multiplication equation. So it's going to look like x times y, or two variables multiplied together, equal to the same two variables multiplied together. And you're going to have a missing variable that you'll have to solve for. And we're not going to look at combined variation. We're not worrying about that. So I'm probably going to I may do 16 and 13 in class so you can see those to make the video short. But all you're going to have to worry about for the homework is working examples like this and looking at identifying the equations. So I don't think this will be too hard for you, but we'll work some examples in class as well.